Hello everyone, welcome back. So now we're into some group problems. So grab a friend, grab a turtle, grab a goldfish. Not in your hand, they're fragile. And let's try to solve this. So what are we trying to do? Well, we're trying to find the force through ED, EH, and GH. Okay, so ED right here, EH, GH, which, oh, nice little cut. Other wonderful thing, it's pretty amazing. None of this matters. If I just choose this section, I don't need any of this right here. So all this craziness, all these forces, gone. Who cares? Method sections is great. You can ignore what you don't want to think about. So here's the plan. Take the cut, analyze the left section. Why? Because it's smaller, less to worry about. And apply your equilibrium equations to solve for it. Now, I'll give you 3 seconds. You're going to go try it on your own, which will hopefully take you longer than the 3 seconds to do, because otherwise you're amazing. Why are you in my class? You should be teaching. And then we'll come back and talk about it. So 3, 2, 1, and you're back, and you're back. So let's look at it together now. First off, I'm cutting right here. But first I want to determine these support reactions. I've got a support reaction in the y direction here, and support reactions right here. And then I need to solve for it. Now you're like, well, why can't I solve after I've cut? It would be so much simpler. In some ways it would be, but then you would have 4 unknowns and only 3 equations. Can't solve that. So you've got to solve for one unknown first. Now we're going to take this in a moment at the A point, because neither one of these unknowns matter. However, all of these forces right here, these 2 right here, this one right here, and this one all cause a moment around point A. This one does not, because as you can see, it has a line of action that goes through point A. So make sure you take into account everything, because sometimes you're going to get confused. You're like, well, this one's in the y direction, so only the y forces matter. That's not the case, because these also cause a moment. They cause a counterclockwise moment, because they're pointing this direction around it. This one also causes a counterclockwise moment, and this one causes a clockwise moment. So it's going to be battling everything else, as you can see right here. Okay, that was definitely way too much drawing on this. Let me erase that. There we go. And so what we get is it's 57.5 kilonewtons. Okay, so we know that. We can now ignore everything else. Thank goodness. And it's so much smaller. It seems much easier. But once again, as always, we're going to try our best to find a way to only have one unknown per equation. Now, if it's going to do what it did last time, it's probably going to be looking to do it around this point. I think that's kind of silly. Why not just do it right here? Because that gets rid of a lot of forces, a whole lot of forces. So that'd be what I would do. Let's see if it does it. It takes it around this moment around point E. It does do that. Now, why that point? Because that force doesn't matter, that force doesn't matter, and that one doesn't matter. All you care about is force GH and force Y, which is pretty simple. One is causing a counterclockwise moment, the one's causing a clockwise moment. So they battle it out. You find that force GH is 76.7 kilonewtons in tension. And then we're going to do some of the forces in the y direction, because only force EH actually has a y component. There's a slope triangle I can get from geometry. And a good one to memorize is this one, because, if you look at Pythagorean theorem, you'll find that this side right here is 5. It's one of the few that has a nice integer number. And so if I then solve that, making sure I don't forget the 40 kilonewtons right here, I get that force EH is 29.2 kilonewtons. Got one equation left, some of the forces in the x direction, or some moments around point H, because it wants to be weird and mess with me. And I can solve for force ED then. I mean, there's a whole bunch of ways to do that. Honestly, this was probably the best way, because in this case I didn't have to worry about taking the components right here. I would have had to take a component otherwise. So some moments around point H, which we can't see, which is right over here, to get rid of both of these forces, and then I can calculate what force ED is, which is simply force times distance, force times distance, force times distance. You got to take into account their direction. This is a horizontal force. I need the vertical distance. This is a vertical force. I need the horizontal distance, and so forth. Okay, with that, we solved the problem. It's honestly not that hard. I mean, if you get used to your equilibrium equations, you can solve these pretty quick. So I hope this helps you, and I'll see all of you next time. Have a wonderful day. Bye-bye.